Good morning, ladies and gentlemen. Dr. John Belkowitz here. I want to apologize, going through a little bit of a cold here and just beating me up a little bit, but I'm excited to go over this today. This is actually going back to one of our projects that we did with my Uncle Richard. It was a hydronic heating project we did last year during the winter, and the question was what to do if there's a unpredicted cold snap. We had a buddy of ours, contractor, do a few slabs. We had a negative 20 drop in temperature from, I think it was 60 degrees out during the day, negative 20 at night. Lost a few slabs. And the question was, what could be done outside of blankets? Because the blankets really didn't help at that point. We lost a lot of the heat due to, the ambient environment. So where could we go? And what we did is we actually set up 2 3-foot by 3-foot slabs that were 4 or 5 inches thick. One slab we put just a blanket on, and then the other slab we sandwiched the hydronic heating system between 2 blankets. And from there, what we did was we took out cores, so we cored out the samples. We did strengths on those samples, and Haley will put the link down below. But what we wanted to go over today was the look of those samples. We actually cored out some extra samples and kept them off to the side, and that's what you're looking at right now. To the left, we have a sample from the slab that was not heated hydronically, and then on the right side you have another sample from the slab that was heated hydronically. So let's go ahead, and this is our overhead shot. And what I want you to notice first of all is the difference in the color. When we have that freezing of water, that water changes its state. It goes from a bulk fluid property, a property that can combine, dissolve with the cementitious particles in the concrete composite, go through the kinetics of cement hydration, and then from there, we get the hardening process. When water freezes, it can no longer combine. At the very idea of it freezing, we reduce the activation energy that's necessary to kick off those thermokinetics of cement hydration. When we do that, we put the concrete to sleep. And what you can see from this bird's eye view is that change in color goes back to the density of concrete, the salts that are leachating out, the salts that were not combined, the hydration process that was incomplete, and what we were left with is this, calcium hydroxide that really was supposed to react, or that calcium that was supposed to react with silica to form that calcium silicate hydrate, and now we're left with a lot of this salt. And the other thing that you can see overhead, and we're about to zoom into this here in a second, is a lot more pores in the sample that was allowed to freeze or just had a blanket on it afterwards, as opposed to the sample that was cured hydronically. So these things are all important to notice, because when we go down to the microscopic, which we're going to do right now with our optical microscope, what you can see, so we're going down first to our frozen sample, and what we saw bird's eye view is these huge pores. Let's go back up to the bird's eye view. That's my sound effect to go back up to the bird's eye view. So now we're at bird's eye view, and what you can see through these 2 samples is just pores on the one that was frozen. All these holes that seem like they're not interconnected, but what we're going to see at a smaller scale is that they are interconnected, but pores everywhere throughout. And there's also some unique sized and distributed pores that came from the freezing of water. Now, when we look at that bird's eye view on the sample that was allowed, or that was hydronically controlled, we don't see as much pores. We don't see those unique surface features, or those features from that frozen water. All right, so very, very interesting to see at bird's eye view. But now let's go into the microstructure. Now, first with the frozen sample, the sample that was allowed to freeze, you see a lot of these pores, big round circles, and on a much smaller scale, if we zoom in just a little bit more, we can start seeing these interconnected pores. But most importantly, all these pores throughout the entire concrete, and then we have these irregular shapes that kind of look like spider webs, if you will, or the remnants, better, of frozen water. And that's exactly what they are. That you're seeing where the frozen water was, the shape that it made to that hydrated cement matrix, and inevitably the problems that occurred. Now let's go back to bird's eye view and and zoom into the sample that was controlled with the hydronic system. Now, we do have pores. You know, the hydrated cement matrix of concrete is a hardened sponge. That being said, in this sample, it's much harder to find those pores at the same volume as we found in the sample that was allowed to freeze. And again, this happens, and of course, we're not seeing those irregular shapes from that frozen water. It's because we didn't allow the water to freeze. Not only did we not allow the water to freeze, but we didn't allow the temperature of the concrete to drop so low that the activation energy wouldn't kick off, and then we wouldn't get those thermokinetics of cement hydration. So we ended up using up that water to create more of that backbone of concrete strength, which ultimately gives us a stronger concrete composite. And that's what we're leading to over this entire thing. You know, why the heck do we care about this stuff? You know, this is something that Haley makes sure that we answer anytime we do any of these videos. Why will our audience care? What are we giving them? What piece of knowledge are we giving them? And that piece of knowledge is, you know, not only did we show you that controlling the temperature of your concrete during cold snaps is important for strength, but also on the microstructure. The microstructure leads back to everything. It leads back to strength, and it leads back to durability, and ultimately, it leads back to service life. And if our expectation is that a concrete that goes through a freezing and thawing cycle will still be as hard and tough as the concrete that's controlled with a little bit of effort and a little bit of work, we will be sorely mistaken. And it will manifest in concrete deteriorating prematurely and us having to come back and really just answering a warranty and service issue. And that is ripping out an in-service slab is extremely expensive. Much more expensive than putting a hydronic system down that is very easy to make with some garden hose, with some blankets, a heating element, a tub, a tank, and a generator, or at least a freaking outlet. So there are methods and measures that we've gone over that are easy to kick the tires and light the fires, get into gear. It could save your slab and make you look like the contractor in the block who can make the impossible happen. So again, today's video is all about the impact of the freezing concept and why hydronic heating is so important during these cold snaps, during this time of year. Hopefully you'll learn something out of this. Let us know if you have any concrete questions, concrete concerns. Don't forget to like and subscribe. Ding that bell for notifications. Go concrete! Beat asphalt!